Hi again. This is the third video. It covers exercise 5 from section 2.5. And this time we're finding the local extrema of the function 2x cubed plus 6xy plus 3y squared. So as usual, we're going to start by looking for the gradient of the function in order to find the critical points. And the gradient in the x direction will be 6x squared plus 6y, and in the y direction 6x plus 6y. The gradient will be 0 when 6x squared plus 6y is 0 and 6x plus 6y is 0. So, well, you see, this 6y appears in both of them, and you're adding it to different things, but you always get 0. So it turns out that this 6x and the 6x squared, they must be the same. Of course, you can drop the 6's in and say that x is equal to x squared. And there's only a couple of numbers that equal their square, particularly x equals 0 and x equals 1. Okay, if x is equal to 0, we'll look at this bottom one. That'll go away, and then 6y will be 0, so y would have to be 0. Okay, and so what if x is equal to 1? Well, if x is equal to 1, then you have 6 plus 6y is 0, so y would have to be negative 1. Alright, so those are the two critical points we'll get. 0, 0, and 1, negative 1. So now we need to check whether those critical points are mins, maxes, saddle points, or whatever. So again, we'll use the second derivative test. So we need to compute the d, which means we need the second partial derivatives. In the x direction, we'll get 12x. In the y direction, we'll get 6. And the xy will this time not give us 0, it'll actually give us 6. So in the x direction, we'll get 6x squared plus 6y. And then when we do the y direction, well, the 6x squared doesn't give us anything, but the 6y does give us this extra 6 here. Okay, so now we need to check these 2 points. So let's see, when we plug in 0, 0, this term dies completely, and so it's going to kill this 6. And so then we're going to be subtracting 6 squared, which is where we get negative 36 from. When we plug in 1, negative 1, well, let's see, 12 times 1 is 12, times 6 is going to be 72, and then we have to subtract 36, which gives us 36. Alright, so when d is negative, yes, we immediately get a saddle point. When d is positive, we need to check what the second partial derivative in the x direction was. So let's see. D is positive, x is equal to 1, we get a 12. So fxx is positive, so we get a local minimum. So in total, we get a saddle point at 0, 0, and a local minimum at 1, negative 1. To look at one of the videos for another exercise, you can click the links here.